Welcome to this section of this course. Today I'm going to speak about LH rule for limits. This formula normally we use when if the limit is lengthy. If you want to do somehow shortcut way, so we use LH rule. Some LH rule is some country. This is a French language, but some country has different pronunciation, so it's better to pronounce as LH rule. Okay, now this in LH rule we have limit of fx upon gx, where x tends to a, x approaches to a. Now these fx and gx should be differentiable. Okay, and when x approaches to a, these functions fx upon gx, if it is of the form 0 by 0 or infinity by infinity, means which is indefinite, means the value of that function, particular function, is if we cannot determine, then we use this formula. Means we have to differentiate fx with respect to x as well as gx with respect to x. Okay, so let's take some simple example. For example, limit of sine of x upon x, where x tends to 0. Okay, now when x tends to 0, sine of x is what? When if I substitute the value of x over here, sine 0 is 0 upon 0. It is of the form 0 by 0. Okay, it is of the form 0 by 0. Here normally LH rule, we apply this formula normally of this form. Okay, there are some others, 0 minus infinity, or infinity raised to 0, 0 raised to infinity. So all these, there are a lot of limits which of the form this. So we can bring this limit up into this, either these two, and we can solve by this LH rule. Okay, now this limit of sin x upon x, when x approaches to 0, it's very near to 0. Let's take x equals to 0. Now sin x, sin 0 is 0, x 0, 0 by 0. Okay, now here, now it is of the form this. Okay, now this same as, let's differentiate this. Now if I differentiate sin x, this is cos x, and differentiation of limit of x tends to 0, differentiation of x is what? 1. Okay, now when x tends to 0, cos of 0 is what? 1. Okay, now this is sin x upon x, where x tends to 0, we are getting the value of 1. Okay, now let's take some other example also. Limit of e raised to x upon x cube, where x tends to infinity. Okay, now in this form, when x tends to infinity, here also infinity, e raised to infinity is become infinity. It is of the form infinity upon infinity. Okay, here we have to differentiate. Okay, now if I differentiate this, limit of x tends to infinity, e raised to x is what? E raised to x. Now differentiation of x cube is 3x squared. Check over here. Okay, now again it is of the form, when x tends to infinity, this numerator as well as denominator is become still of the form infinity to infinity. So again we can differentiate once again. Okay, again limit of x tends to infinity, e raised to x upon differentiation of 3x squared is what? 3 into differentiation of x squared is twice x. Okay, 3 into 2 is 6, twice x. Okay, again over here, when x tends to infinity, this is still x is there. So again I can differentiate it. If I differentiate once again, e raised to x will be as it is, limit of x tends to infinity. Now this will be only 3 to 6, only 6. Okay, now when x tends to infinity, e raised to x upon 6 is what? This is same as e raised to infinity upon 6. Now let's consider example 3. Limit of x tends to 0, x square minus 10 square x upon x4. Okay. Now, when x tends to 0, this of the form is 0 minus 10 0 0. This of the form 0 by 0. Okay. Now, but if I differentiate this numerator, okay, I will be getting twice x into 2 10x into differentiation of 10x is what? Say x 10x. So I am getting more trigonometric value over here. Okay. So if I differentiate up till 4 times, then it will be more complicated. So let's think some other ways. Now if I apply this or from a square minus b square is a minus b into a plus b. Let's apply this way. This is same as limit of x tends to 0, x minus 10x upon x plus 10x upon. Now over here, instead of x4, if I write x cube into xy, because if I write x over here, I can distribute over here. Okay, x upon x means 1 plus 10x upon x. When x tends to 0 become a 1. Okay, therefore I'm giving x cube over here, x raised to 1 over here. Okay, now this is now LH rule is applicable. Okay, so into the particular term also we can differentiate to the particular term. Okay, now this is same as limit of here x tends to 0. Now if I differentiate this with respect to x, this 1 differentiation of x is 1 minus differentiation of 10 is what? Sec square x upon differentiation of x 3x, this is what? 3x square. Okay, this first term. Now this is, if I separate x over here, this over here is 1 plus 10x upon x. Remember this limit is for this also and this also. Okay, now what I'm doing here, I'm applying LH rule over here. Okay, in this particular term. Okay, now if I send limit x tends to 0 over here, this is constant, doesn't have the effect anything. So here limit of x tends to 0, 10x upon x is 1 plus 1 is 2. So 2 I can send outside the limit. Okay, therefore it is 2 limit of x tends to 0. Now what we have is 1 minus x square x is what? We have 1 plus 10 square x equals to sec square x. Therefore 1 minus sec square x is what? Minus 10 square x upon 3x square. Because 1 plus 10 square x is equal to x square. If you want, we can prove this. 1 plus 10 is what? Sine square x upon cos square x. Over here cos square x plus sine square x upon cos x. Cos square x plus sine square x is 1. So 1 upon cos x is what? Cos square x is sec square x. Okay, now here what we have is 1 minus sec square x will be minus 10 square x. Okay, now this I can send 3 outside, minus outside and 2 outside. Okay, this is minus 2 upon 3 limit of x tends to 0, 10 x upon x the whole square, because this square and this square I can take square on bracket and then I can keep a square outside. When x tends to 0, this become a 1. Okay, therefore it's become 2 by 3. Okay, this is the required answer. Now next example is example number 4. Limit of x tends to 0 when 1 minus cos cube x upon x into sin x into cos x. Okay, now you think over here Now if I apply a cube minus b cube, will be a minus b into some term, okay. And now when x tends to 0, this becomes 0 upon 0. Cos 0 is 1, 1 minus 1 is 0. This of the form 0 by 0. Therefore, we can apply L'Hopital rule. Okay, before differentiating, what we can do, we can think something. Now, if I do like this, is same as limit of x tends to 0. What is the problematic term over here? When x tends to 0, now let's rewrite once again 1 minus cos cube x upon x into sin x cos x. Okay. Now if I divide numerator and denominator by x square. Why x square? Because if I divide x, then this x and x will cancel. If I divide x square, the x will get cancelled, and then sin x by x will be there. And then when x tends to 0, the cos x will be 1. Okay. Now if I dividing numerator and denominator by x square, let's see, by x square. Okay. Here 1 minus cos cube x upon x square, limit of when x tends to 0 into, okay, this x and this x gets cancelled, sin x upon x when x tends to 0 become a 1. Okay, so and then this also when x tends to 0, this also 1. Okay, into 1. Okay, when cos x when x tends to 0, it become 1. X get cancel. We have sin x upon x. When x tends to 0, it's become a 1. Okay. Now here, if I differentiate by applying LH rule, differentiating numerator and numerator, let's see how it works. When limit x tends to 0, 3 minus 3 cos of square x, 3 cos square x, differentiation of cos is again sin x, minus minus plus, upon differentiation of x square is what? Twice x. Okay, let me repeat again. Here d by dx of constant is 0. 0 minus this 3 is coming outside. Cos x raised to n means n x raised to n minus 1. 3 minus 1 is 2. Differentiation of cos x what? Minus sin x. Okay, so minus gets cancelled, plus sin x. Now over here, when let's check over here, 3 by 2 gets 3 by 2, I can send outside. When x tends to 0, cos 0 is 1, sin x upon x is 1. Okay, so therefore when applying these limits, they become a 3 by 2. This is 1, and sin x upon x when x tends to 0 also 1. Therefore the value of this is 3 by 2. Okay. Now next sum is 5. What we have is limit of x tends to 0, sine of 3x square upon 3x square is angle of sine. Okay, upon log of cos of 2x square minus x. Okay. Now when x tends to 0, this become 0. Okay, minus 0. Cos 0 is 1, log 1 is 0. Okay. Now and then here sin 0 also 0. Okay. Now what we can do is, if this is the angle of this. Okay. Now we have this formula, limit of sine of theta upon theta, where theta tends to 0 is become a 1. Okay. Now if I divide numerator and denominator by 3x square, because this theta should be same as this theta, then when theta tends to 0, this become a 1. Okay. So now what I will do is, I will differentiate numerator and denominator by differentiate. I will differentiate. We can differentiate, but if I differentiate, it will be somehow lengthy, because differentiation of sine is cos, and then we will get some angle, but over here log is there, 1 upon cos of this. Again we have to differentiate this. Okay, we will try in 2 different ways. Okay, so let's differentiate first. Let's see, limit of x tends to 0. Differential sign is what? Cos x. Cos of 3x square. Again, this differential this with respect to x is 3 as it is 2 twice x 6x into differentiation of this is log is 1 upon cos of 2x square minus x into differentiation of cos is what? Minus sine of 2x square minus x. Again, differentiate this with respect to x is 4x minus 1. When x tends to 0, what is affecting value is what? When x tends to 0 over here, this become a problematic. Okay. Now, what I can do is I can divide numerator and denominator by x upon x upon x. This is how this will be somehow lengthy method. Okay. So now what we can do is we can firstly try to adjust the angles. Okay. This will be somehow lengthy way. Let's try to adjust the angles. Now this is same as limit of x tends to 0 sine of 3x square upon 3x square into I am dividing numerator and denominator by 3x square. Okay, upon you can say upon log of, you can write like this, log of cos of 2x square minus x upon 3x square. Okay, now this is the limit. When x tends to 0, this become a 1, because when x tends to 0, this become a, by applying this formula, this become 1. Okay, now let's consider this term. Okay, now rest this become 1 and limit of x tends to 0. So I will bring up 3x square upon log of cos of 2x square minus x. Now let's apply LH rule. Okay, now let's differentiate separately. Okay, these separate, for example, let's consider this fx and the gx. Okay, let's separate and let's differentiate. Okay, and limit of where x tends to 0, 3x square differentiation is what? 6x upon differentiation of log of this is 1 upon cos of 2x square minus x. Okay, differentiation of cos is what? Minus sine of 2x square minus 1 minus x into divide dx of this is 4x minus 1. Okay, now what are the problems which we are getting? Okay, the problem which we are getting is when x tends to 0, this when x tends to 0 is this becomes 0, twice x square, 0 minus 0 is 0, cos 0 is become 1, this become 1. Okay, this become 1, this become 1, and when x tends to 0 also this become minus 1. Okay, so I will write over here limit of x tends to 0. So we have 6, let's take outside, 6 upon, over here we have minus also, minus, here what we have is minus 1. Okay, here minus into minus plus 1. Okay, this term become when x tends to 0, 0 minus 1 minus 1, minus 1 into minus 1 plus 1, this become 1. Okay, limit of 1 upon, we have minus x upon, we have x over here, sine of 2x square minus x. Again differentiate this with respect to x over here is same as 6 limit of x tends to 0, differentiation of x is 1. Okay, differentiation of differentiation of sine is cos of 2x square minus x. Again differentiate this become a 4x minus 1. Okay, now if I substitute when x equals to 0, cos 0 over here, cos 0 is 1. Okay, so this whole become a 1. What we have is 6 upon x tends to 0 is minus 1, therefore minus 6. Minus 6 is the required answer. Okay, let's try to solve some few more examples over here. Now when limit of x tends to 0, x cube minus 8 upon x square minus x minus 2. When x tends to 2, if I substitute x equals to 2, numerator as less denominator, it will become it is sorted from 0 upon 0, because x cube, 2 cube is 8, 8 minus 8 is 0 upon 0. Now what we can do is we can differentiate this. Let's consider this fx and this is gx. Okay, so we can differentiate this differently as well as this differently. Okay, and let's see how it works. Is equals to limit of x tends to 0. When I differentiate this, it will become what? 3x square upon twice x minus 1. Okay, still okay, if I put if I substitute the value of x equals to 0 over here, this becomes 0 upon what? 0 upon 1, 0 upon minus 1. Okay, this is when x equals to 0, it becomes a 0 upon minus 1. Okay, otherwise what we can do is we can apply here a cube minus b cube over here in this, or you can split this middle term. Okay, but it will be more complicated. Okay, let's keep it like this. Now in this also, okay, in this limit of x tends to a when x raised to n minus a raised to n upon x minus a, differentiating this with respect to x, when x tends to a is with respect to x is n into x raised to n minus 1 minus 0, this constant, upon 1. Okay, so when x tends to x equals to a, this become n into a raised to n minus 1. Okay, this is the required answer.